Welcome back, and hello to those of you who might be new to this channel. I do hope you enjoy the rest of the videos I make. So today we're going to do a bit of physics that I've been meaning to show you for a long time, and I think of all the videos I've made, you'll find the most useful. What we're going to do is we're going to look at the difference between static and dynamic friction. So what encouraged me to make this video is baby Barry is just about beginning to learn to walk. He's not quite up on his feet yet, but he's crawling around on his knees trying to take those first steps. And what he loves doing is getting one of my plastic boxes, and he chucks stuff in it, or the stuff in there already, and he pushes it all the way around the house. Now, we've got two different surfaces in the house. We've got the sort of smooth wooden and tiled floors, and we've also got the carpeted rooms. But what you'll notice is he seems to move the box quite well over the carpet and over the wooden and tiled floors. But what he finds difficulty with is getting started. He finds it hard to get the box moving. But once it's moving, he finds it much easier. And what he's teaching himself about is the difference between the friction that you need to overcome to get started, the static friction, and the friction you need to overcome to keep moving, the dynamic friction. So have a look at the little bits of video I'm showing now and see if you can spot the bit where Barry tries to push the box, tries to get started, and it doesn't quite get going, and he has to push that little bit harder to overcome the static friction. So what we'll do is we'll do a couple of experiments now to try and demonstrate what's going on in this situation, and I'll try and explain the difference and the reasons behind why static and dynamic friction are not the same value. So let's try and explain why static and dynamic friction are different. Every surface that rubs against another one is slightly rough. You might say, well, the wooden floor or the tile floor is not very rough, but if you zoom in with a microscope, you'll see the surface isn't completely flat like a polished mirror. It's slightly jagged. And what happens when two surfaces sit on top of each other is those two jagged parts sort of dig into each other. The pressure causes the layers to be sort of pushed into each other. And then, of course, when you try and move them, you're trying to unlock where these rough surfaces have slightly joined into each other. But of course, once you get them going, they slide much more easily. But as soon as you stop, back again, they link. And so you need a much bigger force to get them going to overcome the static friction than you do to overcome the dynamic friction. So to try and show you what Barry was up to and the difference between the static and dynamic friction, just moving the desks around the lab demonstrate this very well. If I pull on this desk, it just doesn't want to move. But if I get it moving, it now moves quite easily. And as soon as it stops again, I'm going to have to pull much harder to get it going. So think about when it's stationary, the feet interlocking with the roughness of the floor, and when it's moving, those two surfaces sliding over each other much more easily. So let's try and look at this a little bit more quantitatively. So here's a lab weight, and there's a bit of friction on the desk, and a spring balance to measure the force we need to pull it forwards. So what I'm going to do is, I'll just move it across into frame a bit, look at the spring balance as I try to pull the mass forwards, and then look at what happens to the reading as soon as it starts to move. So 6.5, 7 newtons, and there we go. As soon as it started to move, the reading dropped appreciably. So the high reading before it moved was the static friction, and the low reading once it was moving was the lower dynamic friction. Okay, well that wasn't very easy to see, so let's repeat it again, zooming in a little bit. So I'll move the spring balance over here and have a look at the reading on the spring balance as I pull it. So there's the static friction building up and up to a maximum value, and suddenly it flicks back down when we get the dynamic friction, which is lower. So I hope you can see now, as it's pulled past the camera lens, that the dynamic friction is a much lower value than the static friction we had in the earlier picture. So what I always like to do on these videos is talk about an application of the physics we've just looked at. It has to have some real world uses and things that might help you in everyday life. Now, I said to you this was going to be a really useful video. So think about what I showed you with pushing or trying to pull the desk across the floor. What I'm basically saying is, if you need to move something by brute force, now that could be pushing a car to get it started, or dragging a heavy box along the floor, or turning a screw in a piece of wood. Any situation where you've got to get started and then keep moving. Get moving. And as soon as you get moving, keep moving. Because if you keep moving, the force you're working against, the dynamic friction, is going to be lower. But as soon as you stop and have a rest, the surfaces are going to interlock again. You're going to be having to overcome the static friction next time you move it, and it's going to make it much harder. So the lesson here is, if you want to move something, and maybe you've got some friends who are helping you push something like a car or drag a box, get moving and keep moving. And you can explain to them the difference between static and dynamic friction. So I'm sure Barry will spend a lot more time investigating friction and learning a lot more about it. I hope you too now understand a bit more about static and dynamic friction and why it's really important to know about them. Anyway, I'll be making another video soon, and I look forward to seeing you then.